Hello guys. Today we'll be explaining and reviewing the final chapter actually of the Math AHL syllabus. The majority of this chapter is differential equations. So we'll be looking at the three types of differential equations which are separable differential equations, homogeneous differential equations, and integrating by a factor of I. So let's look at the simplest differential equation. Just to make sure while making this video is for people who are HL only, of course, and I'm assuming you already know how to differentiate, integrate with all ways such as U substitution, partial fraction decomposition, or just integrating normally. And of course, I'm assuming you also know differentiation in this chapter and anything about functions in general. I'm assuming you know. So let's write a differential equation here. So it says dy by dx times x equals y. So the question you'll get here is find y. In this case, you already have y is isolated, but you can't just say that y equals x dy by dx. You have to actually rearrange and find y as a function of x, or x as a function of y, sorry. So what are you gonna do? Well, in differential equations, if they are in this form, that means they are separable because there's no addition, there's only multiplication, meaning you can rearrange the derivatives of x and y and rearrange y and x. So what are we going to do here? So the first step to solving any differential equation is getting the x's on the side and a y on the other. So let's get the x and dx on one side. So if we multiply through by dx, we get y dx equals x dy. And if we divide by y and x, we'll get d dy over y equals dx over x. So now I wanted to make sure you know that you can never divide by derivative, so you cannot divide this dy or this dx can never be in the denominator. You always have to put it in the numerator. Now, what should we do? Well, if you know calculus well, you'd know that uh, derivatives and integrals are opposites, like multiplication and division, addition and subtraction. So to eliminate a derivative, you just integrate. So let's integrate both sides. So this integral be 1 over y dy equals the integral of 1 over x dx. So we already know what the integrals here are. This is going to be ln y equals ln x. But there is something missing here. You do not account for the constant c. So you have to add the constant c to one of the sides, one of the integrals. You don't have to add a constant for both integrals. And usually you add the constant with the integral of x, not the integral of y. So now what should we do? Well, actually, in differential equations, you are open to manipulate c as you want. So we can say that c equals ln some other constant a. So now we have ln y equals ln x plus ln a. And we know that ln y now will be equal to ln xa. And now we eliminate ln. So y equals x multiplied by some constant a. ax, let's say y equals ax. And this is a general solution to our separable differential equation. This, of course, is a very easy one. You won't be getting this except in paper 3 where they're asking you about differential equations specifically. Maybe you'll get a question like this, but yeah, you won't be getting easy questions such as this one. So let's look at a very hard question. It is 11 points, and in this question, they actually give you y and x to find c. Such an integration, sometimes they give you in a definite integral with boundaries, they give you values of y and x to find c, and that's what you'll do here. So first, the differential equation is dy by dx equals y divided by ln y multiplied by x plus 2. So if we rearrange, it will be ln y over y dy equals x plus 2 all dx. Integrate now, so we get the integral of ln y over y equals x plus 2, oh sorry, the integral of x plus 2 dx. So this side, we can just simplify it. We know the integral of x plus 2 is very easy. It's going to be x squared over 2 plus 2x and plus the integral constant c. And I forgot to tell you, he gave us that at these conditions y equals e and x equals 2, which we'll be using after we integrate y, we can find c. So let's leave this and let's try to integrate y. We want the integral of ln y over y dy. So here, if you see, if you know how to use integration, you know that this is u substitution, where you let u equals ln y. Why, might you ask? Well, simply, you cannot integrate this. You cannot integrate ln y divided by y. You have to eliminate one of them. And you cannot eliminate ln y because y will never, the derivative of y is simply a 1, and the integral of y alone is y squared over 2. But if you know the integral of ln y, you know that it is 1 over y. So let's use u substitution and see what will happen. So u equals ln y, and du equals 1 over y dy. So if you wanted to change it, it will be u over y duy. So these cancel out and becomes simply the integral of u du, which is u squared over 2. Substituting back, it will be ln y squared over 2. Then bringing down the other section, it's going to be x squared over 2 plus 2x plus c. But here he isn't asking for this. He's asking for the answer to the y. He wants y. He wants you to isolate y. But let's now get the constant c. So y equals e. So we're going to plug in y equals e and x equals 2. So it's going to be ln e squared divided by 2 equals 2 squared divided by 4 plus 2 times 2 plus c. What is ln e? Well, ln e is simply 1, and 1 squared is still 1, so it's going to be half equals 1 plus 4 plus c. Yes, 1 plus 4 plus c. So c equals half minus 5, which will be negative 4.5, which can be also written as negative 9 over 2. C equals negative 9 over 2. Now back to the question. Now we know the value of c. We're going to write it back here with c equals x squared over 2 plus 2x minus 9 over 2. Now we want to rearrange for y, so we're gonna just multiply through by 2 on both sides, so we're gonna get ln y squared equals x squared plus 4x minus 9. Now you want to take the square root here, or we can also no, we'll take the square root. So ln y equals the square root of x squared plus 4x minus 9, and y equals e to the power of this function. And then we have the general solution to the differential equation. Oh, sorry, actually, here this answer is correct, but it is actually plus or minus since you're taking a square root, but it will tell you in the differential equation that y, or the function f of x, is always greater than 1. So if it's greater than 1, it can never be a negative exponent, so we only have plus here. So we would write it like this. Then we say y is greater than 1, meaning y equals e to the positive square root only. So now I've taught you how to solve separable differential equations. This question was an 11-mark question, so you don't want to be missing out on these 3 points, of course. It's pretty simple. You just apply the steps of integration that you know. Now I'll move on to more complex differential equation. Let's start with uh, integrating by a factor. So let me just find the I'm gonna find the question for it because there aren't many questions for integrating by a factor, and I'll explain through the question. So let's go here. Okay. Yeah, calculus. I'm trying to find a question. Sorry. As this is one that looks bad. What is telling me solve the differential equation cosine squared x divided by e to the y minus e to the y dy by dx, and this is equal to 0. And it's telling you the base conditions are y equals pi, and y equals 0 and x equals pi. So unlike the other differential equations here, we have a problem. The equation is not separable, there is addition here. So in order to be able to differentiate y and x separately, we must make the equation separable. So what do we do? Oh, actually it isn't, sorry, this is another question I got. I'm trying to find the question. Okay, I'll find one now. dy by dx plus 2y equals e to the x. So differential equations that you have to use the integrating factor common. Let's leave it in this form: dy by dx plus y multiplied by a function, or x multiplied by a function of y. So f of x, let's say f of x equals a function of another function, let's say q of x. So what is the integrating factor? Well, the integrating factor is denoted by I. It is equal simply to e to the power of the integral of this x right here. The x that is beside the y, if you understand. So you'll find in these questions you'll have two x's, one that is isolated from any y's and one which is beside a y. But in the question here, there is actually no x, but it's still not separable. So what do we do? Well, in the above question, we assume that the x beside the y is 0, so we integrate to the power, so we simply do this. It is e to the integral of 1 dx. So it becomes equals to e to the x, correct? And now you found the integrating factor. So what do you do with the integrating factor? Well, you simply multiply through with it. So if you multiply through the differential equation with this e to the x, we'll find that e to the x dy by dx plus 2y e to the x equals e to the x squared. I'm sorry, e to the 2x. Since we're multiplying, we're adding exponents, so it's going to be e to the 2x. So what should we do now? This is the weird part about differential equations in this specific. So as I said, integration and differentiation are opposites. So in this, I'll show you what to do, then I'll explain. It becomes this: d by dx, the derivative of the following, y e to the x equals to e to the 2x. So what we did here is reverse the equation. If you know, we said that the derivative of the following, this part, is equal to all this, or equal to the part without the derivative, of course. This is the reverse chain rule, but you do not need to know it. You simply need to know that what's inside d by dx is simply y multiplied by the integrating factor. Or sorry, no, it is y multiplied by what is multiplied by the derivative. So here it's only e to the x, but if there was an x, it would be xy e to the x. Okay? So you just multiply through by y and write it as this. So since we've differentiated here, you can write it as y e to the x equals the integral of 2e to the 2x dx. And it becomes equal to simply 1 over, or it's going to be e to the 2x actually, e to the 2x. And since you have e to the x on both sides, you'll simplify dy equals e to the x. Simply. So this one was a bit easy. Let's see another question. So dy by dx minus 3 over xy equals x squared. Again, this time there is an x multiplied by y, so the integrating factor I will be equal to e to the integral of 3 over x, which we can write as 3 outside and 1 over x dx. So it will be equal to e to the 3, e to the power of 3 ln x. In order to cancel the ln and e, you have to make it, put it in this format, where it is ln x cubed by the properties of logarithms. Then these cancel out, it simply becomes x cubed. So let's multiply through by x cubed. So it will be x cubed dy by dx minus, so the x and x cubed cancel, it becomes minus 3x squared y equals x to the power of 5. If I'm correct, let's reassure. Yes, we are. As I said in the last question, we'll write it as this: d by dx of yx cubed equals x to the 5th. Now we can write it as yx cubed equals the integral of x to the 5th dx. Well, that's simple. X cubed y equals x to the 6th over 6 plus a constant a. We're integrating. So if you wanted to isolate y, you divide through by x cubed. So it will be x cubed over 6 plus a over x cubed. And this is the solution to the differential equation. Let's move on to another one, a weirder one, I should say. Dy by dx plus y tan x equals sine x. So again, the integrating factor is gonna be e to the power of integral of tan x. This is gonna be a very weird question, but we'll try to solve it. So what is the integral of tan x? Well, you'll find it in your data booklet simply. It is, I think, secant. Oh, the integral of tan x is actually That's a harder one, but let's see. Let's just write it here down. An integral of tan x. Yes, I think, yeah. So write the integral of tan x dx equals the integral of sine x over cosine x dx. So you want to eliminate denominator, so you let u equals sine x, du equals cosine x dx. So it's gonna be the integral of u divided by cos x. No, actually it's the exact opposite. No, you're letting u equals cosine x in this case. U equals cosine x, du equals negative sine x dx. So it becomes the integral of sine x over cosine x, and if you rearrange it will be du over negative sine x, cancel out, becomes negative the integral of 1 over u du. So it is simply negative ln cosine x if we substitute for u. So if we integrate it by a factor, it's going to be e to the integral of ln cosine x to the negative 1. Cancel out. The integrating factor is 1 over cosine x, which could also be secant x. But let's leave it as 1 over cosine x. So multiplying through, it will be dy by dx times 1 over cos x plus y sine x over cosine x squared x, since tan x is, since we're multiplying cosine squared x, equals the other side is sine x, so we're multiplying by secant x, it will actually be equal to tan x. So again we solve it, d by dx equals y over cosine x. If you want to see, we multiply through by y equals tan x. So we already know the derivative of tan from the other question. So y over cosine x equals the integral of tan, which we got here, which is negative 1 over cosine x. So cancel out, y equals negative 1. Now we move on to the final differential equation, which is homogeneous differential equations. I'll try to get a question here. Sorry, 1 second. So, what is a homogeneous differential equation? Well, in this case, you have dy by dx is equal to some x or a fraction of x and y, as the following. Let's see, x plus y over x. So this cannot be it cannot be solved using an integrating factor, since there's nothing multiplied by y, and it cannot be used, you cannot separate it since there's addition and division. So what should you do? I'm sorry, actually, if in the exams you'll actually be told to use this following substitution, which is the substitution of the homogeneous differential equation. It states that substitute, let y equals some constant v or times x. So it becomes dy by dx equals x plus vx over x. But now you face a problem where you have dy and by dx and you have v and x. So what can you do? Well, let's differentiate y with respect to x, implicitly differentiate. So it becomes dy by dx, because and this derivative of is going to be differentiating implicitly will be x dv by dx, since we're differentiating v, plus v. Since if you differentiate x, it becomes 1 and you to itself, and now you have the derivative. So substitute this instead of the following, so it becomes x dv by dx plus v equals x plus vx over x. X dv by dx equals x plus vx divided by x minus v. So let's try to simplify the right hand side. Well, we can actually take x as a common factor, so it becomes x multiplied by 1 plus v over x, which will be equal to 1 plus v. So x dv by dx, 1 plus v minus v equals 1. Now it becomes separable. So you send everything to the x side, so it becomes v, since if we integrate it, it will be equal to the integral of 1 over x dx. And here we want to use the integration constant, so v equals ln x plus c. Now is the point where you substitute v with y over x, so it becomes y over x equals ln x plus some constant c. So y equals ln x over x plus c over x, which if you want you can set it to any other constant. Oh, sorry, yeah, I wasn't focused. You actually multiply, so it becomes y equals x ln x plus c. So if you want to take the bracket here, and this is the answer for your homogeneous differential equation. I won't be solving more homogeneous because there are very little questions, and most of them actually are this exact question that I just solved. And don't worry of complicating things or thinking if you have to, if a differential equation can be solved by integrating factor or a homogeneous equation. As I've realized, if it is a homogeneous equation, the question will specifically ask you to use the substitution y equals vx. If it doesn't, it is one of the other two, and you'll find out easily if it's separable or not. But I primarily think that the most important differential equation here is, of course, integrating by a factor, which comes up at least once in every IB exam, in one of the three papers at least once. It probably comes up in paper 3 mostly. But more importantly, what I want to stress here is memorize your or practice your integration techniques, because any integration technique can come up here, whether it is normal U substitution like in the last questions, or using trigonometric substitution, or integrating simply, or using partial fractions where you have to decompose and complete the square can come up. And you don't want to get stuck on these things, and if you get stuck, you're basically leaving the whole question on the table, and these questions have a lot of points. Like the ones that I answered here were 11 points each, 11 easy points. So you don't want to not be able to answer these questions by simply not being able to answer a differential equation like the ones I've solved. So I hope I've helped, and thank you.